All right, so today we're looking at lesson 3, vectors and scalars. So hopefully after the lesson you'll understand vectors and scalars. The word scalar is another name for a number. So the number 6 is a scalar. A quantity that is defined by using a number and a unit is a scalar quantity. So 6 miles is scalar. A vector quantity is a quantity that has both a magnitude and a direction. Pushes and pulls are forces, and forces are vector quantities because they have a magnitude and a direction. So if it says 4 miles, 30 degrees due north, that would be a vector because it tells you the direction you're going to go. Or if someone told you to go 30 miles west on I-20. That would be a vector quantity because they told you the direction to go. So if you have seen this video before, you may remember it.
I'm applying for a new protocol to manage a vector. That's a mathematics.
Okay, so if you've ever seen that clip before, then, or you've seen that movie, you've seen that before, you may not have noticed it, but that's what a vector is. It has a direction and a magnitude. So vector is his villain name. All right, so two vectors you can add together graphically by placing the tail of the second vector at the head of the first vector, and either one of the vectors can be first and the other one can be second. And whenever you connect the tail of the first vector to the head of the second, that's called your resultant vector. And so I'm going to draw some colors to help you kind of see what to do here. So we have vector A is our first vector, and vector C is our second vector. And then you start at the tail of the first one, and you go to the head of the third one, and that is your resultant vector. Or if you do it where you have C first and then A, you still get the same vector, A plus C. And so y'all see the little arrows above it? That's how you tell that it's a vector. That little arrow above your letter tells you you have a vector. So note that vector A plus vector C is not equal to just A plus C. So the sum of the vectors is not the same as the sum of the magnitudes of the vectors because you have to take into account the direction. So you can move vectors around because they both have a magnitude and a direction, but it doesn't have to have a fixed position. If you have two vectors that have the same magnitude and same direction, but they have different positions, they're still the same, they're still equal vectors. It's just like whenever in geometry, just because you had a square, if you moved it over here, it was still congruent to the original square. So those squares are still the same. Or if I flip this one, it's still congruent. So same thing with vectors. You can move them around and they'll still be the same vector. So if you have taken me for math before, then this is all familiar. If not, then this is a new concept. So you'll have to really pay attention. You always measure your angle from the positive x-axis. and then we're going to go around this direction. And so they tell us that's a 30-degree angle. The way you write your vector is 4.00 and then at 30 degrees. Now, this is the same vector. It's got a different angle though. It's got negative 330, because if you want to go down and around, you can. You can go this direction. This is still the 30 degrees, and this is a whole circle, which is 360. So 30 degrees from your 360 gives you the 330. And the reason it's negative is because if you start at the positive x-axis and go down, then you're going to have a negative number. So if you start at the positive and go up, if you're going counterclockwise, then it's positive. So it's very interesting to note, seafarers and air navigators measure their positive angles clockwise from due north. But mathematicians and physicists measure their positive angles counterclockwise from due east. So why that is, I'm not really sure, but depending on what profession you're dealing with, it changes how they measure their positive angles. So we are in physics. So we're going to measure starting due east, which is your positive x-axis, and we're going to go counterclockwise. So we're going to add these together. First thing you want to do is to draw an x-axis and a y-axis coordinate. And then you're going to place 20 degrees somewhere on there. So again, you always start from the positive x and you go around, and we're only going 20 degrees. So we're still going to be in the first quadrant, and that's going to be 4. Okay, now we're going to go draw the next one. We're going positive 210, so we start here. This is 90 degrees going here. This is 180 degrees, so we have to go a little bit further. And so if this was 180, the last little bit is 30 degrees. And that is a length of 10. Notice I'm not writing 4.00 and 10.00 because we don't really need them, because 4 and 10 are fine. So what you need to do from here is to make a triangle. And you want to make a right triangle. And this is your x value, and this is your y value. And you're going to use sine and cosine to find your x and y. So if you aren't familiar with sine and cosine, I'm sorry, you're going to need to go over that at another time. You should already have dealt with sine and cosine before taking this class. So the cosine of 20 is going to be x over 4, and then multiply by 4. So you're going to have x equals 4 cosine of 20. And so if we use our calculator, you need to make sure, if you're using a graphing calculator from the classroom, you need to make sure that it's in degrees. So the way that you're going to do that, you're going to go down, and then once it's flashing on the radians degrees, go over to degrees so that it's flashing on degrees, and then hit enter. And so now it's flashing on degrees. It's dark on degrees, not on radians. So if you want to check, go back to mode, and it's dark on degrees now, so we're in the right spot. So you're just going to type in 4 cosine of 20. And I get 3.75, I'll say. And then for y, we're going to get the sine of 20 is y over 4. And then multiply by 4. And you're going to plug that into your calculator. So for sine of 20 gives you 1.36, we'll say. So that's the first thing you're going to do. And then you're going to do the same thing for the other triangle. So we have to make a triangle. You always want your triangles going to the x-axis. You don't ever want to draw it to the y-axis. It's going to mess you up. So always draw them to the x-axis. So again, we're going to find our x. Cosine of 30 degrees is x over 10. multiplied by 10. And so if you plug that into your calculator, you're going to get 8.66. And then to find y, you're going to do sine of 30 equals y over 10. And you're going to plug that into your calculator. And you'll get 5. Okay, so that's the first thing that you do. You have to get your x and y values for each. So now you need to add your x values together and add your y values together. So this first x right here, we went to the right. So this is a positive number, and this y value, we went up. So this is a positive number. For this one, we went to the left. So that's a negative because we went to the left. Those are negative x values. And we went down for our y value, so that's a negative. So whenever we add our x's together, we're going to do the whole decimal place. So you need to go back up to your calculator number, this whole number in the calculator, and then subtract and do the whole number that your calculator gave you. Don't use the estimated one, or you're going to end up with the wrong answer. And so we get negative 4.9. So that's our x value, and our y value, we're going to do the 1.36 number, and then plus 5. So we get 6.36. And that's our y value. And so now we have to put it back into vector format. So the way that you do that is to graph it again. Oh, crud, I added 5. And that should be subtracting 5. It should be negative 3.63. I'm sorry. Okay, so that's our y value. Okay, so now we're going to graph it. So we're going to go negative 4.9, that's going to the left. And then we're going down 3.63 because it's a negative. And the vector is the hypotenuse, and that's what we're looking for, this hypotenuse. So we have to find the length of the vector and the angle of it. So to find the hypotenuse, you're going to do Pythagorean theorem. So negative 4.9 squared plus negative 3.63 squared. And we're going to use our calculator to get that number. So negative 4.9, the whole thing, plus the whole decimal. And then we have to take the square root of that because that's what h squared equals. So the square root of the whole decimal will give you 6.100. And then what was after that? 44. Okay? Now we have to find our angle. So the way you're going to find your angle is to do tangent of your angle, and that's a theta. It's just a Greek letter that we use for angle. And it's opposite over hypotenuse, 3.63 over the 4.9. So the angle that we get when you use your calculator, you're going to do tangent inverse of this number, but we don't want it to be negative. So take out the negative. And then divided by the 4.9 number. But we don't want it to be negative either. So we need to delete the negative. So that'll give you 36.54. degrees. And then to find our actual angle, we always start here and we go around. So this is 180 degrees right here. And then we want another 36. So if you add 180 to this angle, your angle will be 216.54. And so now we write our answer as a vector. So we need to go back and look at our original problem. It said 4.00, that is 3 significant figures, and 10.00, that is 4. So the fewer number is 3. So we're going to have 3 sig figs. So 6.10. 6.10. And then for angles, you always do 2 decimal places for angles. There's no commonly used convention for finding the sig figs for angles, so they just use 2. So for angles, you always just round those to 2. So that would be your answer for that one. So it is a little bit of work. As you get more comfortable with these, it will get a little bit easier. You won't have to write out quite so much. You can do more of it in your calculator. But that's how it works. Okay, so we're going to look at another one. We want to add these together. So if y'all feel like you can do it by yourself, y'all go ahead and pause the video and try it. If not, we can go over it. But I would love for y'all to try it by yourself if you feel like you can do it. So the first thing you're going to do is to graph it. So this one's in the first quadrant. We're going to go ahead and make our triangle with a 67-degree angle, and the hypotenuse is 4. And that's your x, and that's your y. And for this one, negative 190. So when it's negative, you always go down. So that's 90 degrees. That's 180 degrees. So we've got to go a little bit further. And you don't have to worry about your triangles being to scale, because they're really just to help you know what your numbers are. So we went 180, we had another 10 degrees to go. And then that's your x, and that's your y. So now we're going to plug into our calculator. So we're going to get 4 cosine of 67. 4 sine of 67. 8 cosine of 10, and 8 sine of 10. Those should be the 4 numbers that you get. And so over here, our x is going to be 1.56. Our y is going to be 3.68. Over here, our x is going to be 7.87. And our y is going to be 1.38. Now, if you look on this first one, they're both positive because we went to the right and up. But on this second one, the x is negative because we went to the left, and the y is positive because we went up. Okay, so now we're going to add our x values together. So 1.56 minus the x value, because it's negative, gives you negative 6.31, and you get a y value. If you add those two together, of 5.07. So after you get your x and y, you have to come back and graph it. So negative x is going to go this direction. Positive y is going to go that way. So 6.31 and 5.07. We're looking for the hypotenuse and this angle. So to find your hypotenuse, you're going to use Pythagorean theorem. And you can put the negative on the 6.31. You don't have to, because when you square it, it's going to go away. Plus the 5.07. 3 squared, and that's what h squared equals. So you have to take the square root. And so h equals 8.09, what came after that? 95. Okay, and then for your angle, the tangent of theta is going to be 5.09 over 6.31. And so you don't ever use the negatives or positives. You just keep them all positive. So don't try and put negatives on there. So we're going to do tangent inverse. Whoops. Of the 5.07 divided by the 6.31. We need to go back and take the negative out. So that gives us 38.76. And then from there, we need to figure out what our actual angle would be. So this angle here is the 38.76. But we are concerned with the angle to get to that vector, which is 180 minus 38.76, which is 141.24. So we know that our angle is 141.24 because we took out this part right here. Together, those two add up to 180. Then our sig figs, here we have 3, here we have 3. So our final answer should have 3 sig figs. So 8.09, but then there's a 9 here, which is going to round this up to a 10. So 8.10. And again, that would be your answer. Okay, so for your homework, make sure that you do 1 through 20 tonight so that we can go over any questions that you have tomorrow.